Hi there, folks. Today we're looking at proving angles congruent. And we already know a couple things about angles. We know some of the definitions in terms of supplementary angles and complementary angles and what certain angle measurements are, that kind of stuff. We also have one or two postulates about angles. We have the angle addition postulate. We know that the smaller angles add up to the bigger angle. We also have the linear pair postulate, which told us that, hey, a linear pair is supplementary, that kind of stuff. And I mentioned some of those because we're going to start to use those to form bigger ideas in terms of what we can use in our toolkit. So like when we think about proving things in math, in geometry and mathematics and that kind of stuff, we start with these basic tools of definitions and postulates, but then we use these bigger tools, all right? And these are called theorems. And so what we're going to do, a definition, a postulate, those are things that are just kind of given. They're accepted to be true without any proof. But now we want to build a more complicated tool that we can use later, all right? And that's called a theorem. It's a conjecture, a statement that we prove to be true. So I'm going to use some of the tools I have. I'm going to use those definitions and postulates to prove a bigger item to be true. And then once I do that, that theorem, I can use that as much as I want down the road. I no longer have to prove it again. Once it's built, once it's constructed, I own it and I can use it as much as I want, okay? So the thing we're going to prove here is that the vertical angles theorem. And so when you look at this, it says given that angle 1 and angle 3 are vertical angles, we want to prove that angle 1 is congruent to angle 3, okay? And when I take the approach here, we could get really into some very nitpicky, nitty-gritty details, all right? The approach that I'm going to take here is I want you to just be able to have reasonable justifications. All right. And this is the thing that makes doing proofs in geometry so difficult, is because there's a little bit of an art form to it. All right. And if we were really being really strict and technical about this, this particular proof could be 12 steps long. And I'll talk about that in a moment. But I'm willing to let this, kind of be a little bit looser as long as we have a reasonable justification. All right. And so the idea here is we can't make too big of a leap. We kind of have to take baby steps, but I'm not going to be really strict about those baby steps, okay? So, for example, we're just going to do a proof here, all right? We're given that we have vertical angles. I want to prove that angle 1 is congruent to angle 3. This is kind of the vertical angles theorem. See, once we're done with this, we'll know that vertical angles are congruent. See, that's what we're trying to show here, all right? We're trying to show that vertical angles are the same. And so I'm going to do my statements and my reasons here. And so I start with the thing that I know. I know that we have vertical angles. So angle 1 and angle 3 are vertical angles. And feel free to abbreviate. I use that little angle symbol all the time. And that was given. All right, the problem told me that. All right. And now from here, here's where some of that nitty-gritty can kind of get us. All right, those little details. Technically, from the perspective of, doing this with every single step possible, the definition of vertical angles is they're formed by opposite rays. So next, I would have to say that and they're not labeled, but I would have to say this piece and this piece are opposite rays, and that this piece right here, this ray and this ray are opposite rays, because that's the definition of vertical angles. And then I could say that each of those are lines, because that's what opposite rays form a line. And then I could say that, hey, now I have a linear pair because these are lines, okay? But we're not going to get into all of those little details. Instead of breaking that up, all right, I'm not going to label all this extra stuff. We kind of have a general working definition of vertical angles instead of the opposite rays thing. We know that vertical angles are formed by lines, okay? And so in terms of a reasonable justification, I'm not going to care about that really nitty-gritty detail here. The reasonable justification is that we can jump right to the fact that, hey, because those are vertical angles, I know I have lines here, which makes something like angle 1 and 2 a linear pair. All right, that's a reasonable step, a reasonable justification in my mind, okay? So I'm going to jump right to angle 1 and angle 2 are a linear pair, okay? And I could say the same thing about angle 2 and angle 3. Those are also a linear pair. I missed an A in there. And again, abbreviate, but make sure I can understand your abbreviation. And see, I know those are linear pairs because our working definition of vertical angles was that vertical angles are made by lines. So if you want to just abbreviate that and say, hey, vertical angles formed by lines. Boom, I even used the line symbol, okay? Now from here, if I have a linear pair, all right, two angles that make a line, all right, I know something about those two angles. I know that those two angles are supplementary angles. And again, depending on the teacher, they might let you jump right to the measure of angle 1 plus the measure of angle 2 equals 180 degrees, all right? But if we're kind of doing those smaller steps, we would say, hey, that means that angle 1 and angle 2 are supplementary. And then I could say the same thing about angles 2 and 3. And see, I know that because we have a special postulate that said, hey, when I have a linear pair, they're automatically supplementary. All right, and it made sense to us. All right, and you can come over here and say, hey, that's the linear pair postulate. All right, if you don't remember that it was a postulate, that's okay. Just describe what you know. Just say, hey, linear pairs are supplementary. Done. Okay, you don't have to tell me it's a postulate. And frankly, the names of these postulates are arbitrary. They're based on whatever textbook you happen to be looking at. If you could look at one textbook and call a postulate by one name and call the same postulate by another name in a different book. Some books, back when I was in school, they didn't have names for 90% of these. They just called it postulate 1, postulate 2, postulate 3. But all those postulates, those numbers weren't set in stone. They were based on the textbook. Okay, and so just be aware of that. You know, some of these naming protocols are arbitrary. All right, and some of the postulates we'll get to later won't even have names, but in another textbook they might. Okay, so you're better off just describing what you know. If you don't remember that it's a postulate, that's okay. As long as you know it to be true, you're in good shape. Okay. Now, because I have supplementary angles, I know what supplementary angles are. Those are the ones that add up to 180 degrees, right? So the measure of angle 1 plus the measure of angle 2 equals 180. And same thing here, the measure of angle 2 plus the measure of angle 3 equals 180. Okay? And I know that because that's what supplementary angles are. I just said in the previous step that these are supplementary angles. I can say, well, that's what supplementary angles are. That's a definition. And again, if you don't remember that that's a definition, that's okay. Just literally write the definition. Say supplementary angles are the ones that add up to 180. That can be your justification, all right? The next step now, if you look at what I have, see, this is where students fall apart. They're like, okay, I was following with geometry up to this point, but now we jump away from geometry for a second. Look at the two equations I just wrote. Okay, measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 2 plus the measure of angle 3 equals 180. If I have two equations that equal the same thing, it means those two equations are equal to each other, right? Couldn't I now say if each of those equals 180 that the measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus the measure of angle 3? And so when you do this, this is kind of one of those algebraic steps. And you know, it's hard for our brains to kind of switch gears like that. I was doing geometric type of things, and all of a sudden I'm jumping into some algebra. And the justification here, you know, you could call it the transitive property, depending on how you stated this thing. You could say that, hey, measure of angle 1 plus measure of angle 2 equals 180. 180 equals measure of angle 2 plus measure of angle 3. Therefore, measure of angle 2 plus measure, okay, transitive property, all right? Or you could say, hey, that's the same thing as 180, so I can substitute that in for the 180. So whether you say transitive or substitution here, I'm not going to care that much, okay? You could really use either of those as a justification. Technically, it's the transitive property if you state it in the right way, all right? But substitution when we plug things in for other things, okay? And you could look at it that way, all right? So just keep that in mind. Again, It's about reasonable justification, all right? So now what we have is we have this equation, and maybe you're looking at this, well, simplify the equation, people. Remember, even though this is like a literal equation, even though there's not like actual values here to solve the equation, you could act like you're solving the equation. Couldn't you subtract the measure of angle 2 from each side? So think about that for a second, and maybe you want me to show you that step kind of in here. Right here, if I subtracted this guy from each side, you see what I would be left with? All right, so imagine that being subtracted here. I'm running out of space, so I got to delete it. But subtract that from each side, and here's what happens. You end up with the measure of angle 1 equals the measure of angle 3. Right? If I took away and all I did was I subtracted the same thing from each side. That's the subtraction property of equality. See, we're still in that kind of algebra mode here. And again, if you don't remember the exact name there, just say, hey, I'm allowed to subtract the same thing from each side of an equation. Give a reasonable justification. All right? And then the last piece, see, we're still not quite there. You might think we are. We were trying to prove that those angles are congruent. And you're probably looking at it going, well, yeah, I know they're congruent. Well, you know they're congruent because they're equal, right? But let's state that they're actually congruent. And see, that's just a slight difference. Remember, the definition of congruent is when things have the same measurement. So I'm just going to say the definition of congruent. Okay? And so the idea here is we went from a measurement to the actual shapes being the same. Okay? But see, here's the thing. We just proved that vertical angles are congruent. We started with 1 and 3 are vertical angles. We just proved that they're congruent. Well, now we never have to do it again. We just proved that all vertical angles are congruent. By doing it in that one situation where it was generic and I didn't have actual measurements, because I did it using definitions and postulates, I know that that is always going to be true now. So the vertical angles theorem, if two angles are vertical angles, then those angles are congruent. And now I can use that in any situation. I can use it to solve for certain things. I can use it in other proofs. So the next time I want to show that vertical angles are congruent, I don't have to show these 7 steps. I can just say, hey, these are congruent because I know vertical angles are congruent. We've just added that to our toolkit, okay? And so if I look at something like this, here's an example where we're doing a little bit of math and using that theorem in kind of a more practical way. Here I have 2 vertical angles. I know that vertical angles are congruent, right? It asks me to find the measure of each of these. Well, I know that vertical angles are congruent, so the 4x equals the 2x plus 21. I know that because I just proved the vertical angles are always the same. And now I can solve. I'm going to subtract the 2x from each side. Oh, I guess I haven't been showing that. And I'm going to divide each side by the 2. That's right, we're big now. You don't need to show me divided by 2 on each side, Mr. Jansen. That equals a 10.5. Again, it didn't ask me to find x. It asked me to find the measurement of each angle. You got to plug that 10.5 in here for x. If I plugged it into this guy, let me grab a different color here. That's going to be a 42. And here's the thing. You already know that this other one should be 42 based on the fact that these should be the same. But if you want to check it, it's really easy to check it. Plug that 10.5 in for x and see if you get a 42, all right? And you'll find out that you do. So there's my answer. There is 42 degrees, okay? How about something like this guy? Given that angle 1 and angle 4 are congruent, I want to prove that angle 2 and angle 3 are congruent, all right? So ready? Statements and reasons here. I'm going to start with what I know. Oh, sorry, I've been doing the rest of this in blue, right? Yeah, you can't stop now, Mr. Jansen. That's what I'm used to. So I know that angle 1 is congruent to angle 4. And I know that because the problem said so. It was given. But think about what we just went through moments ago, right? Yeah, just think about that for a second. What did we just prove a little while ago, right? Didn't we prove that vertical angles are congruent? See, I don't have to go through all that. I can immediately say stuff like this. I can go, hey, angle 1 is congruent to angle 3. Boom. I can say that, angle 4 is congruent to angle 2. Boom. And why can I say that? Because vertical angles are congruent. That's one of the tools in my toolkit now. See how much time and effort that just saved me? If I don't know that, if I don't have that theorem in my toolkit, I have to go through all those steps I did on the previous page. I have to include those 7 steps as part of this thing. And you can do that if you want, but that's a crazy person thing to do. Now that we know vertical angles are congruent, I can use that wherever I want, okay? And now from here, if you haven't noticed it already, let's see, I want angle 2 to angle 3, right? So right here, angle 2 is congruent to angle 4. Angle 4 is congruent to angle 1. Angle 1 is congruent to angle 3. Therefore, angle 2 is congruent to angle 3. All right? See, this proof is essentially done at this point. I can jump to the thing I wanted to prove right away and say, hey, angle 2 is congruent to angle 3. And once again, that's essentially my transitive property. Now, could we say that that's really a series of substitutions? I guess, technically substitution usually doesn't, usually we kind of use that with measurements, but I'm fine if we're going to do that. But it's the transitive property, okay? And so here's what we just, here's what we're heading up to here. Oh. If we look at this guy, the congruent supplements theorem, okay? So this is another theorem. So once again, once we're done proving this, we've got it forever, and it's going to be awesome, okay? It says angle 1 and angle 3 are supplementary. Angle 1 and angle 3 are supplementary. I want to prove that angle 2 and angle 3 are congruent, all right? And this one might seem more obvious. If 2 angles are supplementary to the same angle, don't those 2 angles have to be the same? All right, and so we're thinking about that. Well, let's put that into a step-by-step proof of this thing, okay? So here we go, ready? Let's start with what we know. We know that angle 1 and angle 2, I wrote angle 2 twice like a crazy person. Let me fix it. Are supplementary angles. I know the same thing about angle 1 and angle 3. Okay, and that was given. The problem told me so. The problem said so, and I believed it. Well, good. Got to listen to what the problem says. But now think about this for a second. I know what supplementary angles are. Supplementary angles are the ones that add up to 180 degrees, right? So that means that the measure of angle 1 plus the measure of angle 2 equals 180. This should seem familiar because we kind of did something similar to this a moment ago. See, I know that each of those adds up to 180 degrees because, well, that's what supplementary angles are. All right, that's a definition that we have for supplementary angles. Mr. Jansen told us so. Uh-oh, my computer's starting to get slow. Okay, so that's just a definition. Again, if you don't know that it's a definition, you don't remember to call it a definition, that's okay. You just say, hey, supplementary angles are the ones that add up to like 180. You just write the definition of the thing, okay? And now from here, once again, I have two separate equations that each equal the same thing, that each equal 180. And again, depending on how I state it, I could say that this is the transitive property. Or if you want to call it substitution, I'm okay with that. Again, my goal is reasonable justification. Okay. And now from here, once again, we're in that same boat of, let's subtract the same thing from each side. If I subtract the measure of angle 1 from each side, I end up with the measure of angle 2 equals the measure of angle 3. And if you literally want to write that subtraction kind of in the space in between and scoot this step down, that's okay. You're allowed to do that if that makes you feel a little bit better. That was the subtraction property of equality. And again, if you don't remember what that is called, just describe it. All right, describe it. Reasonable justification. And then the last step, hey, if these are equal, that means they're congruent. Done and done. But now, once I've done this, and again, that's just what congruent means. Okay. Once I've done this, I never have to do it again. If I ever run into this situation where I see that, two angles are supplements of the same thing, I can immediately say, hey, these two angles are congruent because, I know that. That's a theorem I know. All right. And again, if you don't remember, it's the congruent supplements theorem. That's okay. Again, the name is arbitrary. Just describe it. All right. So next time we want to use this in my justification, I can just say, hey, if two angles are supplements of the same angle, then they're congruent, all right? And that can be my justification. I don't have to remember the name, all right? But that's what we've just proven. If two angles are supplements of the same angle, then guess what? Those two angles are congruent, all right? Or if two angles are supplements of congruent angles, like if I know that 1 and 3 are congruent angles, and I have two other angles that are supplements of each of those things, I can immediately say that the supplements are congruent, okay? The congruent complements theorem here is the same thing, except instead of supplementary, we have complementary. Instead of 180, we have 90. I'm going to do the exact same proof. So a little bit of magic here. I'm going to just paste in our old proof and then just change some of the stuff. You ready? Same thing, except instead of supplements, it's complements now. Instead of 180, it's 90 now. Okay. Done and done. I just did this whole proof. Pretty awesome, right? Everything else is the same, all right? So following that same logic, all right, this is going to be the same thing. So the congruent complements theorem, if two angles are complements of the same angle or they're complements of congruent angles, then those two angles are congruent. All right, I don't have to go through all that stuff ever again. The right angle congruency theorem, all right angles are congruent. We're not going to go through and prove that one. It's a pretty easy proof. The definition of right angles is that they're 90 degrees. Then we could say that their measurements are the same. Then we could say that they're congruent, okay? And then supplementary congruent angles theorem. If two angles are congruent and supplementary, then each is a right angle, all right? Because again, if I have two things that have 180 and each of the angles are the same, they each have to be 90, all right? And even though that seems so obvious that maybe we should call it a postulate, because we can prove it using some of our postulates and definitions, that's why it ends up being a theorem, okay? We didn't go through and prove all of these. Even the congruent complements, we didn't really go through and do the proof because it was the same thing. But I want you to understand that once we've proven one of these things, it's really easy to justify and prove some of these other things, all right? And so now we just keep adding these things to our toolkit. So the next time I need this, I don't have to prove it. I've already proven it. I can just plug it in and say, hey, these things are congruent because they're each complements of this other angle, all right? These things are congruent because they're both right angles, all right?